Righty-ho, so we'll just do a little bit of using our graphics calculator as well as just our common knowledge of trig to solve this question. Alright, so we've got a Ferris wheel. It's being modelled by this equation here. Heights in meters, time is in minutes. So here we go. Where is the passenger at time t? So if we look at our equation, we remember how we write our notation. We can just simply say, well, that means it's h of 0, and that's asking us to replace t with 0. So wherever we see t, we're just going to replace it with a 0. So it becomes 20 minus 19 cos, and instead of 2 pi times t, it's 0. Do we need a calculator to work that out? I'd hope not, because 0 times anything is 0. So this whole thing here now becomes 0. Okay, and I hope that we know that cos of 0 is 1 because you know the graph. So when 0, we know that it's 1 up here. Okay, or for those of you who prefer the unit circle, right, at 0 degrees here, cos is the x-axis, so it's 1. Either way. And of course, look, if you don't like that, feel free, type it in your calculator. So cos of 0 is 1, so that becomes 20 minus 19 times 1, which is 19, and we get it's 1 metre. So initially, the passengers are 1 metre above the ground. Okay, what about B? Change of colour is required. At what time is the passenger at the maximum height? Okay, so I think now it recalls for our calculator. So we can grab that and type in our equation, which I've already done. Okay. We want to set our scale, so we're going to go Shift View Window. Now, if I just went to Standard, right, we've got some issues here because we know that time can't be negative, so we're going to set that to 0. Our maximum, we would like to set that to how long it takes to complete 1 revolution. Now, we don't actually know that yet, the wavelength. We read the question. That's what we're going to do in part C. So let's actually do that now, just to make our life easier. Right? So to find how long it takes to complete 1 revolution, that is finding our period. So remember, the period is 2 pi over b. Okay, we've got 2 pi divided by, what's our coefficient of t here? It's actually 2 pi over 3. So this becomes 2 pi times 3 over 2 pi. They cancel, and we've got 3. So what we're saying is it's going to take 3 minutes to complete 1 lap. Let's see if that is true. So we pop in the 3. Now, I'm looking at my y, min and max, 10 and minus 10. I mean, what is this 19 doing? That's making the graph go up to 19, down to minus 19. And then we're adding on 20, okay? So 19 plus 20, 39, I know is going to be my maximum. It clearly can't have negative length, otherwise it's going to go into the ground. But I'm not concerned about that. I'm just going to press enter. Okay, go yep. And now we go shift, zoom, so F2 and auto. And there's our graph. Now I like to go back into our scale and just give my max and min a little bit of a buffer. So I'm going to actually put in -1 because I want to be able to see the x-axis, and just have a buffer. I'm going to go 42. Okay, and there we go. All right, so now coming back to C, B, sorry, at what time is the passenger at a maximum height? Because we've got this, now we can just say G-solve max. So at what time? 1.5, so 1.5 minutes, and the maximum height is 39. So let's go back here. At what time is the passenger maximum height? So that's going to be when time is 1.5. We've done that using technology. So 1.5 minutes. Okay. in the first revolution of the wheel. Okay, how long does the wheel take to complete one revolution? Well, we've done that over here. Sketch the graph for one revolution. Yep, so you can do that nicely. So look at your calculator to help you. But again, let's see if we can do that. So we'll do that as D over here. We'd use a ruler, okay? We know that we've got 0 here. We've got our maximum cycle length is 3 minutes. Okay, if we look at our graph, at 1.5 it's got your max. So we'll pop up our max here using our cosine knowledge, right? As we set up here, that's what our cosine looks like. It starts at its maximum and then goes down. But why is ours actually starting here and going up? Right, that's because of this minus in front, okay? And without knowing or using our calculator, we know the minimum would have been minus 19 plus 20. So we know that this one here, and again, that's where it starts at 0. We know that that's 1. And our maximum, yes, we knew from the graph it was 39, but again, it would have been 20 plus the 19 here. That gave us that 39. All right, so again, it's a sketch. It doesn't have to be exactly to scale, just getting sure that we've got that sort of, and that would keep on going and going up and down and so on. But it's only asked us for one cycle. Pop in that 1.5. I like to label a crucial point, so let's label that as 1.539. Okay, and that's clearly labeled as 1, and we'll call this is our x-axis, which is the t, and our y-axis is the height. Okay, what else do we have to do? So we've sketched. The passengers can see his friend when he is at least 13 meters above the ground. During what times is the first revolution? So come back over here. We can go G-solve and do our X-calc. So when is it above? So we can go X-calc. When is the Y value at 13? All right, we get that. However, I prefer this. So I'm going to go into the equations. I'm going to pop in 13 because I can now see the visual. So it's at these 2 points when it's above 13 and you can see their friend. How do we find that? G-solve, intersect. Okay, so F5 and F5 again. So 0. What is that? 5, 6, 9. So we're up to E. So we've got, they're going to be able to see it when it's greater than 0.569 minutes and 2.43. 2.43 minutes. Okay, so that's just fancy pants for saying time can be in between 2.43 and 0.56. Practice with your calc. Hope that's helped.